Today I'm going to show you how to calculate the volume of a solid of revolution that is created by rotating a region around a line other than the x or y axis. As you recall, the general form for this is actually the washer method is pi uppercase r squared minus lowercase r squared, indicating the inner and outer radius. Inner radius, the smaller radius being lowercase. Outer radius, larger radius being uppercase. Then this is going to be dx or dy depending upon how the washers are swept. The general form for the shell method is 2 pi rh, again dy or dx, and we'll discuss that further in the examples. The region that we are going to revolve is bounded by y equals root x, y equals 0, x equals 9. I'm going to revolve that region around the line y equals 3, and I'm going to use both the washer and the shell method. I've already sketched out the regions. This first example around y equals 3, because it is a washer, it's pi uppercase r squared minus lowercase r squared. And as I look at the region, I can see that these would be swept horizontally. I know then this is a dx situation, and my bounds are then in terms of x, and x is going to go from 0 to 9. Again, when I look back at this washer, this outer radius, if I think of another washer drawn here, that outer radius is always 3. It's unchanged. The inner radius does vary as we sweep these washers across horizontally. This distance from this line of that we're revolving around to the x-axis is a distance of 3. So this quantity, as it changes, being vertical, I'm going to call y. So this remaining quantity, which is representative of that radius, would be 3 minus y. But I can see here that that's not consistent with the fact that this is a dx situation. So I'm going to re-express this y in terms of x. So I'm going to rewrite this as pi 0 to 9, the large radius 3 squared minus small radius 3 minus root x quantity squared dx. And when I expand this, I have 9 minus 9 minus 6 root x plus x dx. Doing a little bit of simplification here with the integrand, I find that I have 6 root x minus x dx, and when I'm all finished, this is 135 pi over 2. The second method that I'm going to use is the shell method. I know this is calculated using 2 pi RH, and when I look at this, I can see that these are going to be generated vertically, so this will be a dy situation. My bounds then are 0 to 3. The radius for this shell is similar to what we had here. It's changing. It's the difference between this distance and this changing distance y. So again, this radius is 3 minus y.
the height also varies. And it's going to be the difference between this total distance of 9 and this changing quantity x. So similar to the situation that we had here, I can't leave this in terms of x because this is a dy situation. Since y is root x is going to be y squared. So my height now becomes 9 minus y squared. And when I expand this, I have 2 pi from 0 to 3, 27 minus 9y minus 3y squared plus y cubed dy, and again, I should get 135 pi over 2.